Good day, everyone. So today let's talk about some cases of free-falling objects. So let's say we have here a man and it drop a ball here, starting from this part until it reach the ground. Take note that when we are releasing an object at rest, the initial velocity is always equal to 0. And let's have here the height. The height here is 7 meters. Let's try to solve the first one. How long to hit the ground? So we're talking about here the time for this ball to reach the ground. So the first one that we're solving is the time for each to reach the ground. So what kinematic equation that is helpful in order for us to solve this problem? 1, 2, or 3? For instance, we all know already some of the given. We all know already the initial velocity, which is 0 meter per seconds, and the value of gravity, which is 9.8 meter per seconds. If we use the kinematic equation 1, since there's a time here, we don't know the value of the final velocity yet. So we cannot use kinematic equation 1. So here, we can use the kinematic equation 2. Let's rewrite. So we have here change in y is equal to initial velocity times time minus 1/2 gt squared. We all know that the initial velocity is 0. The time that the one we are looking for minus 1/2 times the value of gravity, which is 9.8 meter per second square, times the time that we're looking for. Now, the change in y is this one. Concern something here. Change in y, if we expand it, it will result to the final position minus the initial position. We all know that the initial position starts here and the final position starts here. Therefore, if our basis is the ground, the final position is 0 minus the initial position, which is the same as the height, is equal to 7 meter, equals 0 times time is already 0. So it became 0 minus 1/2 times 9.8 meter per second square times the time square. Now let's continue calculating. We have negative 7 meter equals negative 1/2 times 9.8 meter per second square is negative 4.9 meter per second square times the time. So let's divide negative 4.9 here, both sides, so that t squared will left on the right side. So it will result to 1 + 1.43 second square is equal to t squared. However, we're looking for time only. So let's try to get the square root. Eventually, we will get time is equal to 1.2 seconds. So therefore, it will take 1.2 seconds for the ball to reach from its initial point to the ground. So 1.2 seconds. So that's the first item. Let's answer number 2. In number 2, our concern is the velocity. How fast is it moving just before hitting the ground? So we're looking for the final velocity before it reached the ground here. So we all know the value of time already, so we can use the first kinematic equation. which is final velocity equals the initial velocity minus gt. We all know that the initial velocity is 0 minus 9.8 meter per second square times the time, which is 1.2 seconds, the one that we solved a while ago. Therefore, it will result to the final velocity, which is negative 11.7 meter per second. So this is the velocity before the ball hit the ground. Now let's continue discussing solving for free-falling bodies for the second case. In the second case, it is where the ball is thrown up. So what happened when you throw the ball up? So let's analyze the diagram first here. As you can see, here, we have here a man throw the ball up until it reached the maximum height. So this is the maximum height it reached. Now, what I want to highlight here is that when you throw the ball up, you didn't just release it. So therefore, we have already the value of initial velocity. So for instance, in our given, the initial velocity is 6 meter per seconds. So that's the initial velocity. And now, the height here with respect to the ground is 7 meter. But the height being reached by the object is this one. This is the maximum height that the object reached since you thrown it upward, and then eventually it fall to the ground. So this is the maximum height. Now let's solve first on number 1. So how long to get the top? So we all know the given that we have the initial velocity, which is 6 meter per seconds. Now, since our concern is the value of time to reach the top, let's apply what we have learned in free-falling bodies. In free-falling bodies, the maximum height, at the maximum height, the velocity is 0. It's the same thing here. Once the ball or the object reach its maximum height, the final velocity or the velocity at the top is equal to 0. And then eventually it will fall downward. So therefore, the final velocity at the top or the velocity at the top is 0. Knowing that information, we can now solve for the value of time using the kinematic equation number 1. So final velocity is equal to initial velocity minus gt equals 0 equals 6 meter per second minus 9.8 meter per second square times time, the one that we're looking for. And then let's transfer 6 meter per second on the left side. So it will result to negative 6 meter per second equals negative 9.8 meter per second square times the time. Since our concern is the time, let's divide negative 9.8 meter per second square both sides. It will result now to t equals 0.61 seconds. So therefore, in order the time it takes for the ball to reach this maximum height here is 0.61 seconds. Now, let's solve the next question. Find the maximum height. So we're looking for the maximum height here. So this is the maximum height being reached by the ball. So what is the maximum height? So we all know already the value of time to reach the top, which is 0.61 seconds. So it is starting here from this point to this point. So that is 0.61 seconds. So we can use the time from this point to this point because this is the maximum height. So let's try to solve for it. So we can use now the second kinematic equation. So we have your change in y is equal to b initial times time minus 1/2 gt squared. Now, the initial velocity still is 6 meters per second times the time, which is 0.61 seconds, minus 1/2 times 9.8 meter per second square times 0.61 second square equals 3.6 meter, because seconds will be cancelled, minus 1.8 meter, which is equal to 1.8 meter. However, this is not the maximum height yet because we only compute starting from this ball, from this position up to this position. So this is only the max, this is only the 1.8 meter. But our concern is the total height, the maximum height. So we all know that we have here 7 meter. In order for us to solve for the maximum height, we need to add the 7 meter given plus this point until it reaches the top, which is 1.8 meter. Therefore, the maximum height is 8.8 meter. So this is the maximum height. Okay, so now let's solve for number 3. Find the speed before hitting the ground. So our concern is the final velocity before the object reach the ground. Knowing all the informations that we already know, we can now use or solve for the final velocity using the third kinematic equation. So we can now solve for the final velocity. So we all know that b final squared is equal to v initial squared minus 2 change in y over g. Okay, so we are now solving for the final velocity. So we have here the initial velocity, which is 6 meter per second square minus 2 times. Okay, class. Here, don't be confused. When we say change in y, we're talking about the displacement. So we're talking about here the final position minus initial position times g. Now, the initial position is here. So at the initial position, the height we all know is 7 meter. And the final position is 0, of course. So in displacement, we're not concerned about its maximum height. Our concern is only the initial position and the final position. So therefore, we have here, let's compute 36 times 6, 36 meters square per second square, minus 2 times the final position, which is 0, minus 7 meter times 9.8 meter per second square. Therefore, we have now 36 meters square per second square times 2 times negative 7 meter times 9.8 meter per second square equals, we have 36 meter per second square plus 137 meter per second square. Okay. It will result to now with 173 meter square per second square. But our concern is the final velocity only, not the final velocity square. So we're going to get the square root of this one. So therefore, it will lead to final velocity equals 13.16 meter per seconds. However, since the final velocity is moving downward, so the value in the final velocity is negative. So we have now this one. Now, let's proceed to the last given. Find the total flight time. So here, our concern is the total flight time from its initial point until it reached the top, until it reached the ground. So that's the total flight time. So to solve that, we're going to use the second kinematic equation, which is the change in y equals to initial velocity times time minus 1/2 gt squared. So our concern is the time. Again, the change in y is the final velocity, the change in y is the final position minus the initial position is equal to initial velocity times time minus 1/2 gt squared. So we have here 0 minus 7 meter equals 6 meter per seconds times time minus 1/2 times 9.8 meter per second square times t square. So we have here negative 7 meter, 6 meter per seconds times time, 1/2 times 9.8 is negative 4.9 meter per second square times the time squared. Now we're looking for the t here, the value of t. Here we can apply what we learned using the quadratic formula. But first, let's rearrange the values. We can transfer negative 7 on the right side. It will result to this one. Negative 4.9 meter per second square t squared plus 6 meter per seconds time plus 7m. So our concern is to look for the value of t. So let's transfer this one. So again, negative 4.9 t squared plus 6t plus 7. In solving for the value of t, we can use the quadratic formula. So this one, the one partner with t squared represent A. The one partner with t represents B. And the constant represents C. So using the quadratic formula, we can solve now for the value of t. Cos negative b plus or minus b squared minus 4ac over 2a. So this is the formula. Solve for it. So we have negative 6, substitute the values, plus or minus 6 squared minus 4 times negative 4.9 times 7 equals 2 times negative 4.9. So we have here negative 6 plus or minus 36. 4 times 4.9 times 7, you have positive 137.2 times 4.9, you have negative 9.8. we have now -6 plus or minus and now separate the values. The other t, -6 plus the square root of 173.2 is about 13, so approximately 13.16 something. Let's say 13 over -9.8. And the other value of t is t equals -6 minus 13, -9.8. So let's solve. 7 times -9.8. This one, we have -19, -9.8. So here, 7 divided by 9.8 will result to negative, time here is negative 0.71, which is not a value of time because it's negative. So here we have 19 time divided by 9.8. It will result to positive value, which is time 1.94 seconds. So this is the total flight time.